just to kind of remind us where we've been. There's been a request for me to develop some kind of an outline for the things we've been studying and going over, and I'm more than happy to do that, and I'm working on that. And so we'll hopefully be able to give that to you, or at least make that available for anyone who wants it next week, next Sunday morning. So the affirmation we're studying is that four-step sort of argument there, that God exists. You have to establish that. Is that more likely to be true than not? Is it reasonable? Is it rational? And then that the Bible's His Word, and then that the Bible teaches a particular proposition or a particular doctrine. If those three things hold, then it seems to follow inescapably that the teaching has to be true, whatever that teaching may be. If God's the source of all truth, and He teaches us something through His Word, then that has to be truth. The first part of that argument is that God exists, and even though it seems strange to me sometimes to think about why we would argue something that seems oftentimes to be plainly obvious, we do have to make an argument for that. There are people who honestly question the existence of God. There are people who have been very much confused by those in the world who have an atheistic slant, who are militantly atheistic. That has done a lot of damage in the world of ideas. And so the Christian has an obligation to study the existence of God. We're doing that by studying the cosmological argument now. And we want to look today, we've already put forth two cosmological arguments. We want to look today at some responses that are given by the world to the cosmological argument. They know the argument, they've heard the argument, but for one reason or another reject it. Why is that? Is there a good reason for why that might be? You could frame the question in this way. How does the science establishment, so whatever science is, of course science is something that you do, something that's done by individuals, but how does the science establishment as a whole answer the cosmological arguments? Okay. Well, the answer that they give is some variation of the idea of a Big Bang. So there is some explosive moment incredibly far back in the distant past at which the universe came into existence in consequence of the Big Bang. And so we want to take some time today and think about answering that question, and looking at the science establishment's answer to that question, to that possible explanation of the Big Bang. But before we get too far into that specific question, I want to back up a little bit and think about the science establishment in general. What is the science establishment? Who constitutes it? Who is able to speak authoritatively about what science knows? Is there any individual that we can point to and say, this individual is a spokesperson, a legitimate spokesperson for science? On top of that, how does science work? What's the nature of it? What are its limitations? What is it able to tell us? What is it not able to tell us? And so forth. So I want to take just a few minutes and talk about some of these issues that really give us a description of how science works, at least to some extent. So in the world of science, as you know, models are put forth to attempt to describe reality in one way or another. And so an observation is made, or a collection of observations is made, and then theorists go from those observations to trying to describe them by some coherent model that explains the things that have been observed. Okay? So some examples of this that you might be aware of, or maybe have studied in science class. For some of us, that was longer ago than others. But so you may have studied, for example, Galileo's ramp experiments, where Galileo was studying, and if you haven't studied them, they're in and of themselves interesting and worth your time. But Galileo, to understand gravity, set up ramps at various levels of incline and then rolled metal balls, solid spherical balls, down the ramps through a groove in the ramp to study the motion of the ball as it went down the ramp. So, of course, it started from rest, and then he'd release the ball, and it would pick up speed as it proceeded down the ramp. Well, he wanted to understand gravity. He wanted to understand how gravity influenced motion. And so he set up an experiment. He had models of how reality works, of how gravity works. He might have started with a linear model that says that the ball will move equal amounts of equal distances down the ramp in equal amounts of time. Of course, that falls flat. That model is obviously false because the ball picks up speed as it rolls down the ramp. And so he would then go on to another model that maybe better fits the observations that he has on his ramps. Another example also dealing with gravity comes from the same period of time roughly when Kepler was studying planetary orbits. So Kepler took observations of the motions of the planets, in particular Mars and others, but mostly Mars, as it moved through the night sky. And then he put that together with an understanding of, or a model of, how the Earth moved. And so based on how Mars moves in the night sky, given the fact that Earth is also moving, he put those things together in a model and came to the conclusion that planetary orbits are what are called ellipses. And so planets go around the sun in a particular pattern. And so he had a model of how that worked, and then he looked to the observations to see if that's true. Well, the same is true with Big Bang models of the universe. So we have observations. We can look out into the night sky and make observations about maybe distances or motions of galaxies and stars and so forth, and then try to put that into a model that summarizes the observations that we see. Okay? What is the best way to explain those observations? Well, the Big Bang is what has been put forward as the secular scientific explanation of the history of the universe. Okay? The Big Bang model is what's called a cosmology, which means it explains existence. It explains, or tries to explain, the origins of the universe from the beginning. Now, you notice in this slide I underlined the letter S, because there's more than one model that's been put forth. As a matter of fact, there are dozens of models, each with dozens of variations to try to accommodate different observations and different details. And so we'll talk about that a little bit more, but it is important to recognize, and I'm thinking about this in the context of talking about it with someone I know, someone who's studied something about the Big Bang and so has questions about it. What can I say? One point that needs to be made is that there are multiple cosmologies that are thrown around in science today. There is not necessarily a single cosmology that's universally accepted, although there is one that's more popular than others currently. To understand, though, the idea and the use of models, the use of science in general, we have to acknowledge that science is a human endeavor. Science sort of takes on two forms in my mind. On the one hand, you have the ideal of science, which ideally is pursuing nothing but truth. So the goal that you want to arrive at truth by study of the physical world. That's the ideal version of science. But then given the fact that science is done and can only be done by human beings, there is a real science, okay, the science that actually exists, and that science is hindered by the same shortcomings of mankind that hinder all other pursuits that we're involved in. It is fundamentally a human endeavor. I sort of motivate this in my mind by 1 Corinthians chapter 8 and verse 1, where Paul's talking about knowledge. And he talks about knowledge in the context of doctrine. So revealed truth in the New Testament, that truth was being revealed. It was very new at the time. But Paul talks about the value of knowledge and the danger that knowledge has, a danger that accompanies knowledge. In the last part of 1 Corinthians 8 and verse 1, Paul says in the New King James, knowledge puffs up. Knowledge puffs up. In other words, knowledge has a tendency, if it's not carefully used and appropriately used, has a tendency to make an individual arrogant. And that is true. The more you understand, the more I understand human nature, the more that truth sinks into my mind. Knowledge makes arrogant. And if it's not carefully handled, that will be the case again and again. If it's true, thinking about the context of 1 Corinthians chapter 8, that revealed spiritual knowledge from God, revealed through the Holy Spirit, through the apostles and so forth, if that kind of holy knowledge can puff a person up, can make a person arrogant, then certainly knowledge gained in a secular context, in the study of nature, going through college and so forth, certainly that kind of knowledge can lead a person to arrogance as well. And this, I don't think this point can be overemphasized, that science is subject to the same sort of trappings that we run into in any time we're dealing with human nature. Sorry, I forgot to advance that slide. David Berlinski is a mathematician. He's quite elderly now, but he's a famous mathematician. He's done a lot of writing, particularly in the area of cosmology. So his particular brand of mathematics is the sort that you need to study cosmology, like the Big Bang theory and inflationary theories and other theories that explain the origin of the universe. So David Berlinski said the following, and I think his quotation is generally accepted to be true, and I think it points out this idea that science is beset with challenges. Okay, he says almost all cosmologists have a favored scheme, and he's talking about Big Bang models, particular Big Bang models. When not advancing their own, so everyone has their favorite, he says, when not advancing their own, they busy themselves pointing out the problems of the other ones, enumerating the deficiencies of the other ones. So when I'm not talking about my own favorite theory, I go around and sort of nitpick or find fault with the others. Okay, and everybody does this, is what he's saying. So everyone is defending their own, but is fighting against or pointing out faults in the others. And so he also points out the fact that having constructed an elaborate scientific orthodoxy, that is, scientists have built up and got into the position of a broadly accepted, generally accepted, popularly accepted view of the origins of the universe. They've built up this scientific orthodoxy that everybody has to believe, whether you're a scientist or a non-scientist, you just need to take our word for it, sort of thing. Cosmologists have acquired a vested interest in defending it. And I think that is very true. Now, David Berlinski is not a creationist. He's not even a theist. He's not a believer in any real sense. He calls himself an agnostic, at least did, last I heard. But so he says he has, that cosmologists have a vested interest in defending their positions. Okay? And so that's a human nature kind of observation. That doesn't have anything to do with science. Okay? The Big Bang may be true or false. What he's saying here, though, is a statement about human nature. And I think that's something we need to be aware of and be thinking about. So in science, the way things are approached is that they're approached under the heading of a paradigm, or a general way of thinking about the universe. You can almost think about it as a worldview for science. It's a foundational set of assumptions that everyone uses so that work can be done, so that you can further the science itself. And so under the Big Bang paradigm, or a particular Big Bang paradigm, there are individual scientists working on specific parts of that problem, of that question. And so they're working under this heading on a small problem, typically, okay, a comparatively small problem. Now, the paradigm itself is inherently naturalistic. Inherently naturalistic. That is, the assumptions of the Big Bang are from A to Z, absolutely philosophically naturalistic. There is no allowance no allowance whatsoever for anything outside of the universe to have affected its beginning. There's no allowance whatsoever for anything supernatural. It's ruled out a priori. It's ruled out from the very beginning, before you even open the science book, okay? Before you even begin to do an experiment, before you even begin to study the nature of the universe, or it's where maybe it came from, the assumption is it happened naturally. It happened of its own accord, you might say. It had nothing to do with a supernatural creator, okay? Now we're talking about the strictest form of atheistic Big Bang theory, okay? The assumption that it's naturalistic. It is based in natural observable causes. Another point we need to be aware of is that most cosmologists never question their paradigm, their overarching way of thinking about the world. Most cosmologists never question the overarching paradigm. There are a couple of reasons for this, but it's based in the fact, I think, that they are invested in their paradigm. They're invested in the assumption that it must be true, and I'm just working out some detail of the theory down here sort of at a lower level. I'm not questioning the overarching issue. I'm studying a small detail, a small maybe prediction that it might make, or a small detail that relates to some part of it. They are invested. What do I mean by that? To study cosmology, I mean, just to try to give a scope of cosmology as a science, the only universities that can study cosmology in a robust way, okay, or in what we in the modern world call a robust way, is if they have a particle accelerator. Okay, you've heard of particle accelerators. They're enormous contraptions. They span sometimes miles in length. And so there will be these tunnels, typically underground, where particles are accelerated to high speeds and then crashed into other particles, and then the effects are observed. What's the point of that? The point of that is most universities don't even employ a cosmologist. Okay? So at West Liberty University, for example, there are no cosmologists. Universities close by, there are no cosmologists, okay? So we're talking about something that's highly, highly specialized, that you have at only the largest research, institutions, universities, that are, you might say, far away, okay? But individuals are invested in cosmology. So to be a cosmologist, you go to school for, 100 years, and you study a particular brand of cosmology. You invest tens, if not hundreds of thousands of dollars potentially in your schooling. And then once you're done with school, you fight to get a job and get into a position where you can do some research in your particular brand of cosmology. And once you get into that position, you're obligated. I mean, in what sense are you obligated? It's not like there's a rule, but there is a lot of pressure at the very least to produce research under the heading of the cosmology that you are studying. So you are invested. To question the paradigm would be something like throwing your job out the window in many cases. Okay, not every case, but in general, there's a lot of truth to that fact. So cosmologists are incredibly invested in their field of study. Okay, and their cosmology is such a large pursuit that they're working in small pieces of it, okay, and so very rarely have the opportunity to come out and say anything authoritatively about the overall paradigm or to question it at all, okay? So most cosmologists never question the fundamental paradigm, okay? Now some do, okay, but most do not. I think it's fair to say. Another point we need to think about, though, again, is specialization. So under the heading of a particular cosmology, you study a small peace again, okay? So it's important to realize that very often tunnel vision affects research. So individuals studying are working inside a particular context on a very small problem, again, relative to the overall paradigm, and so they are highly specialized, and you might say so specialized that they can't see the light of day outside of the world they're working in. Going back to the idea of being invested in your particular brand of cosmology, if you want to obtain funding, which all researchers do, you realize funding is limited. Just like money, all resources are limited. Funding in particular is limited. So if you want to obtain funding, you have to work in such a way as to attract funding to yourself. So you have to look like you're working within a particular accepted paradigm that's likely to produce useful research, useful results. And so chasing funding is important, okay? It's very important. In many institutions, if you don't obtain funding, that's it, okay? You're not welcome at the institution. So funding is limited and has to be obtained, and so it's chased at all costs, you might say. And finally, it's often motivated by selfishness, and this goes back to Berlinski's comment a minute ago. The motivation to protect one's own theory, one's pet theory, is very strong. Okay, it's very strong. It has a lot of accompanying accolades, okay, and a lot of benefits of that sort. So it is very tempting for individuals. This is a human nature question. It's very tempting to pursue your own theory. And there are many examples of this in the history of science. For self-interest, for purposes of self-interest. This is a quotation from Stephen Hawking, who died earlier this year, back in March. He said, the new inflationary model, this is one example of what people would typically classify as a Big Bang model, although it's a variation, but it's a cosmology. The new inflationary model, he said this in the early 90s maybe, was a good attempt to explain why the universe is the way it is. This is Stephen Hawking. Now again, he's not science, he's a scientist, so he cannot speak authoritatively for everybody, but this is what he said, and obviously highly regarded scientist. He said, in my personal opinion, now this is an informed academic opinion, he's not... The new inflationary model is now dead as a scientific theory, although a lot of people do not seem to have heard of its demise and are still writing papers on it as if it were viable. So this goes back, I think, to the idea of selfishness. So people are working on their own theories, they're trying to develop this, and remember, it's just a model that tries to explain the universe. It's an abstract model that tries to make predictions and match up with observation. People are working on their own individual models in such a way that the bulk of scientific consensus can move away from a particular model, and people continue going on writing papers on it as if it were still a reasonable explanation. Okay? And this kind of thing, I think, illustrates human nature, at least to my mind. Okay, before we get again into the objections that one might make to the Big Bang, I want to look at some of the inherent limitations to knowledge that we can obtain from science. So what can science tell us? What is it able to tell us at its best? Okay, even if it were in this ideal form that we mentioned earlier, where we're pursuing nothing but truth, we care about just the truth of how the universe works. There are still inherent limitations, even at its very best, even if we had unlimited resources to study, to make bigger and bigger telescopes and so forth, there are inherent limitations to scientific knowledge. This is something I think that naturalists fail to acknowledge, and something that should be pointed out to someone who is working under that heading. You cannot verify on the basis of science the validity of logic itself, the validity of mathematics itself. These things are outside the realm of scientific understanding, scientific investigation. They have nothing to do, science has nothing to do with justifying or verifying mathematics itself or logic itself, along with other issues that are sort of meta-scientific. So mathematics, for example, is used as a presupposition for science, so that for science to try to explain mathematics or justify it would be going in a circle. You start with science, science uses mathematics, and so science itself could not be explaining mathematics. It's using mathematics and so forth. Another thing that science cannot tell us, and this is a philosophical point, but it cannot tell us that there are other minds outside of my own. Now, I assume while I'm standing up here that you're listening to me, and in your mind, you have a sense of self. You think you know who you are. You're an individual, and you're observing things from your perspective, and we're looking at each other, and we are independent, separate minds, separate from one another. I'm in my mind, you're in your mind, and we are observing the world from our relative perspectives. But there's no way that science can verify that. There's no way I can know that on the basis of the scientific method, that everything I'm observing right now and seeing isn't just a figment of my imagination, or that you are not just a figment of my imagination and that you don't independently actually exist. And so science is not able to give any kind of an explanation of that fact. Science presupposes that. It supposes that observations that I make are real and valid and can be studied. Another thing science can't explain at all is our statements of value. What's the value of a human life? What's the value of doing a good deed? What's the value of anything? Okay, of gold. What's the value of even physical things? Science has no statement to make with regard to that sort of thing. Not the same for beauty or aesthetics, art. Science has nothing to, or very little to say about that sort of thing. And science cannot even make the statement that it itself is valid. Science cannot validify itself. Science presupposes the scientific method, but it is not able to self-validify. And so it's stuck. What's the point? Should we throw out science and reject it altogether? Well, absolutely not. I think an appropriate understanding of science is that it's created by God, that it's a part of the dominion that God instructed us to have over the world, that we understand it and can manipulate it and can use it and so forth. Okay? But we also have to realize, we have to be aware of the fact that any good thing can be abused. Any good thing is subject to being misused. So all of these are rational beliefs. It's perfectly reasonable to believe in logic and mathematics, to believe that you are a mind outside of my own, that you are independent and exist, and from your perspective that I'm independent and exist. It's reasonable to believe that values are a real thing, and so forth. All of these are rational, reasonable beliefs, but they cannot be established on the basis of the scientific method. Okay? And that's an important thing for us to realize. Okay? And again, this gets at the issue of humility. Am I being humble with my pursuits, okay, as a scientist? Okay, that's the question. A summary of this, I think, is before we get into the answer of science and the answer of the Big Bang, is that science is sometimes guilty, in particular cosmology is guilty of confusing the how, describing how things work, predicting what will happen under given circumstances. That's the realm of science. We confuse in science very often the how with the why. Why are things the way they are? Science has no answer to that question. Science is by nature descriptive. It explains how things work. It's very good at that. It's incredibly good at that. You think about just the cell phone in your pocket. It's a cliche thing to say, I guess, but the technology involved in our cell phones is mind-boggling. It's mind-boggling. It's invisibly connected, for one thing, to cellular towers at great distance from where we are. And it can send information reliably across open space. It's incredible, the technology. And all of that technology is predicated on scientific understanding. Science is good at describing how, but it confuses the how with the why. Okay, without taking any more of our time, I want to get into some specifics. And really, I think a lot of these specifics we've seen already regarding the secular explanation for the universe, but I want to go through them again and kind of highlight some of the issues that are involved. In the first place, the Big Bang, or any variation of it, okay, so this isn't specific to a particular model, this applies to all models, all cosmologies, it is that it violates the first law of thermodynamics, and we talked about this a while back. So the first law of thermodynamics says that matter and energy cannot be created, cannot be destroyed. So the total amount of universe present at one moment will be equal to the total amount of matter and energy in the universe at a later moment. Okay? So there is no change in the total matter and energy. But think about what the Big Bang requires us to believe. It's not optional. If you want to believe in the Big Bang, and this is indisputable, no one would disagree with this, you have to believe that reality went from no matter and energy. Why do you say that? Well, we're talking about the creation of matter and energy. The universe itself. We went from none, zero, no matter and energy to what you see today. That is a violation of the first law of thermodynamics. The answer comes back something like this, and again, I'm not a cosmologist, I'm not an expert, you should read more about it on your own. But the answer comes back something like, at the very beginning, at, say, the moment of the Big Bang, the laws of physics as we know them did not apply. And so there was a different set of laws that applied, and that's the conditions under which the Big Bang occurred. And then once the Big Bang progressed a couple of seconds into the future, normal laws of physics came back into play, and now gravity is like we see it, and now electromagnetic forces are like we see them, and so forth. What's the problem with that? The problem with that is that there is no way to experimentally verify any of that. Not only do we not know what the laws would have looked like, but we have no access to experiments that could be done under some different set of physical laws. The only physical laws we have to work with are the ones we currently have. And so it's impossible to test any scientific statement along the lines of, well, there was a different set of laws governing the universe. That is a desperate attempt, in my opinion, a desperate attempt to make something come out of nothing, and we've talked about that. So it violates the first law of thermodynamics. Enormous amounts of matter and energy were created, which is a violation. It violates the second law of thermodynamics in the second place. So I think something like an analogy along the lines of you've heard the analogy of a tornado or some violent storm rushing through, or some violent explosion rushing through a pile of parts, and somehow assembling and organizing and building, constructing something that's highly functional, something like a 747 aircraft, you've heard that analogy, is just about appropriate. Okay? So if you have a junkyard and a tornado goes through it and somehow assembles all of these complicated parts into a working, functional whole, that's the analogy for what the Big Bang is supposed to have done. We started with enormous amounts of uncontrolled, unconstrained energy being shot out into the void, and somehow out of that, over time, tremendous order, to the level of even your brain was created. That's a violation of the second law of thermodynamics, which says that things tend toward disorder on the whole. Things tend toward disorder, equilibrium, and uniformity. And so that's a violation of all Big Bang models. Another objection that has to be made is that the Big Bang does not answer the question of causality. So sorry, I'm advancing things and you're not seeing them. The Big Bang does not answer the question of causality. And again, I hope you're thinking about this in terms of, and I hope I'm thinking about this in terms of how I could present these objections to someone I know, okay? If I'm talking to someone I know, I'm not going to say to them, well, let me lay out the first premise, and let me lay out the second premise, and let me draw a line there, and then lay out the conclusion. That's not how we talk to each other, okay? That's not how people relate to each other. The point of this is to get clear in our minds, straight in our heads, to the best of our ability, what the objections are, what the arguments are, what the reasons are, and then take those and make them real and put them into answers that can be given in conversation. So an objection to the Big Bang is that it doesn't answer the question of causality. So the first cosmological argument that we looked at said every effect must have an adequate cause. Certainly the universe is an amazing effect, and so therefore it must have a cause. The Big Bang does not answer the issue of causality. Again, we said a couple of weeks ago, or maybe last week, there are no known exceptions to the law of causality. The Big Bang should not be any exception, but you must believe that it is. You absolutely have to believe it's an exception to the law of cause and effect to believe in the Big Bang. But then the question is why? Why should I believe that? Give me a reason to believe that that's the way things worked, other than I just don't want to believe in God. I just don't want to accept the existence of a higher being. That's not a valid answer. You're ruling out possibilities before you've looked at the evidence. So it does not answer the question of causality. Does anyone have any questions or thoughts or observations you'd like to make there before we go any further? You wake up sometimes and you realize you're just doing this for 30 minutes.
Something else to note. I forget who the speaker was. It was one of the scientific community, and their explanation for how this all came about. Remember that they're trying to get something out of nothing. Their explanation went something along the lines of there was a period-sized mass consisting of nothing that was about 25 pounds that exploded and made the universe. So their explanation is nothing blew up, and because nothing blew up, everything happened. And they have to take these weird stances because they can't do it logically. Mm-hmm. They have to try to find some way for nothing to make everything, because they don't want to submit that, yes, there was a creator. Mm-hmm. And then, it sounds kind of mean, but that's what it's all going back to. There's a lack of wanting to accept that there's a God. And then you have to think, well, why are they doing this? Mm-hmm. So... Yeah, that's a good point. That's a good point, and it's tempting. It's tempting to jump right away to what you just said there at the end, which is the only reason anyone would believe in the Big Bang is because they don't want to accept that there is a God, and I agree with that almost to the very top. I want to leave room, though, and I think we have to leave room for the possibility that there are people out there who are honestly questioning, and they're honestly intimidated. I mean, science can be an intimidating thing, and so we have to leave room for the possibility that there are people who sincerely want to know, and for whom these arguments are exactly what they might need. But yeah, very, very good point, Jesse. Thank you. Other questions or thoughts? Yes.
It's interesting to me, Chad, that science in general doesn't want to admit the existence of anything outside the natural universe. But to explain the universe, that's exactly what they have to do. They have to go outside the natural laws, as you're articulating here. Yeah. They have to violate their own rules just to explain the universe.
Right.
Yet they won't acknowledge the existence of God.
Right, absolutely. And then the question becomes, why accept one far-out explanation over another explanation? Yeah, very, very good. Thank you. Any other questions or comments or thoughts? Okay, so it doesn't answer the question of causality. Next, the Big Bang does not answer CA2. What's that? The cosmological argument number 2, okay. So that's just a lot of letters to type in there. So it doesn't answer the second cosmological argument either. Does anyone remember what that was? What that argument said? So we talked about cause and effect. Cause and effect was sort of the basis of the first argument. The second one had to do with what? Does anybody remember? Evolution. What was it?
Theological.
Close. Everything had to have a beginning. Yeah, do you remember that? So everything that has a beginning has a cause, we said, okay? And then the universe had a beginning, therefore the universe had a cause. So a second way of reasoning is to look at the fact, and really this, in my mind, is almost the same as the causality issue, but look at the fact that the universe had a beginning. And again, this is palatable to scientists because scientists believe the universe had a beginning. Okay, and so that's at least useful. Okay, so everything that had a beginning had a cause. How does the Big Bang answer that? It doesn't answer it at all. It doesn't even attempt to answer it. The Big Bang argument says that suddenly, as Jesse said, nothing exploded and gave us the universe that we now have. That's not answering the issue of causality again. How did things come to exist? Well, there was a Big Bang, but it doesn't address the issue of causality. It doesn't answer the argument that everything that begins to exist must have a beginning. Okay, so we have about a minute left here. I would like to again give you a chance to ask any questions you might have. Next week, we'll get into another line of argument, which is the argument from design and order in the universe. So we've kind of stayed away from that approach to things so far. The arguments we've looked at so far are based on existence. Why is there something rather than, what's the opposite of something? Nothing. Why is there something rather than nothing? We haven't really looked at any particulars of the universe. We haven't talked about why there maybe is design. Okay, that's the question we want to study and look at starting next week. So thank you very much for your attention. We will pick up at that point next Sunday morning. Thank you.